technically off duty, right? Okay, looks like we're going. All right, so building on what we just did on these costs, so we had this way of thinking about explicit and implicit cost. But where we left off last time was our total cost was equal to our total variable cost plus our total fixed cost. So all of our operations of our business, we can theoretically put into these two categories of fixed and variable cost. Does it change with the quantity being produced? So my grocery store example last week was the number of beeps. Beep, beep, beep. All of a sudden the cash register is ringing, right? And so we have costs being incurred because I'm operating. Whereas the rent and insurance and some other things would fall into this fixed cost category where they don't vary. All right, so a lot of times it's convenient to look at a per unit basis. So what would I need to do to my total cost? Let's just focus in on total cost. If I had $1.3 million worth of total cost, how would I look at my cost per unit? What would I do to my $1.3 million? Oops, I want to get this going. Please ask the host to give you permission. I am the host. Okay.
Recording in progress.
Gotcha. Okay. What would I need to do? I thought I heard somebody. Was that you, JC? Divide by the total units, right? So if I have $1.3 million worth of total costs, right? We're talking the rent, the labor, the machines, everything, electricity bill, attorney's bills, advertising, all of the total costs, $1.3 million, and I produce 1.3 million dealy bobs. What is the average cost per dealy bob? $1.3 million worth of total cost, and I'm making 1.3 million of these. How much is it? $1. So my average cost per unit is $1. All right, so from a formula perspective, all you're doing is dividing by the units produced, dividing by the quantity that you made. Now, going back to math class, what I do to one side of the equation, I got to do to the other side of the equation. And so I've got a Q over here, so that means I got to divide this by Q and divide this by Q, which gives us a really convenient way to look at cost. The average total cost of production is equal to the average variable cost of production plus the average fixed cost of production. So you should have this memorized. Commit this to memory. It's not that hard, really. You guys are master's students, so you should commit this to memory, put a little star, memorize this. This whole thing has a whole bunch of information wrapped up into one expression. Maybe there's multiple expressions depending on how you argue, but there's about, 5 or 6 formulas here. So the first formula was total cost is the sum of variable and fixed. And then we've got, that means the average total cost is equal to the sum of average variable and average fixed. Average total cost is this formula, average variable cost is this formula, average fixed cost is this formula. So we got about 5 things wrapped up into this one expression, and that kind of is handy to know right off the top of your head as you get into different types of problems in the course. All right, so what does the sucker look like? So we're going to do a lot of graphing. We did a little bit of it last time. If I was to graph the total fixed cost equation in this two-dimensional space of dollars and quantity, what would it look like? Total fixed cost. Total fixed cost. Horizontal line. All right, so here's my 1.3 million. Right, if we're talking 1.3 million. And if I produce one gizmo, at 1, my total fixed cost is 1.3 million. If I produce 100 gizmos, my total cost is total fixed cost rather, is 1.3 million. I think I did total cost before, so sorry, I don't mean to be confusing that. Maybe I should pick something else, but too bad. All right, how about at 200 units? My total fixed cost is 1.3 million. So my total fixed cost curve is 1.3 million. Again, this is going a little astray from what I think, if I remember right, we can go back and review the tapes. I think I said total cost of 1.3 million. I'm now saying, let's just say that's our rent, right? That's our fixed cost. Is everybody cool with that picture? No matter what my quantity is, my cost is fixed. So my next question is, what does the average fixed cost function look like? What does the average fixed cost function look like? I see some hands waving. I'm looking online just to make sure I don't try to ignore you guys too much here. Average fixed cost. JC, I saw you waving some sort of hand. Semicircle. No. Wrong. One of my econ majors. He let me down. JC, how could you do this? It's not the U-shape. I'll come back to you later. There's another one that's U-shaped, but this is not it. The average fixed cost. Jonathan?
Total fixed cost divided by quantity?
Yes, but what does it look like?
Okay.
So this is the shape,
Okay.
even though it's a straight line, right? Because at each quantity, you know, that sucker is straight across.
So
Would it be a negative line?
Okay, negative what? Yes, I'm with you. Give me a little more information. I don't know if it's mirrored or not, so with you holding up your pen, I'm not sure.
Oh, so I mean like 1.1, that would be at 1.3.
Okay.
And then at 100, if you divide 1.3 by 100.
Yeah, right. So it's going down. So it's negatively sloped. I don't know if that's where you were going with that, right? Yes, so it's negatively sloped, and it's pretty steep. Check this out. If I produce 1 unit, it's 1.3 million worth of fixed cost. My rent divided by 1 gizmo. But what if I produce 2? What's the average fixed cost of 2? $650,000. We cut that sucker in half. Now this is not kind of scale, of course. 100's way over here. But if this is a 2, we're already cutting that sucker in half. So it is like dropping like a rock, right? And then if we go to 3, it's at 300,000. If we go to 100, what is it? 100, 1.3 million. Some of you have some regular calculators. Don't pull out your phones. All your phones should be off the desk, by the way. I forgot to give some of you are new in here, so make sure your put that away in your backpack or something. What is it? 13,000. Yeah, we went from 1.3 million to 13,000. So I mean, we're way down here already, right? So this is 13,000. 1.3 million divided by 100 gizmos, that is 13,000. So what this thing's doing is it's asymptotically approaching the horizontal axis really fast, right? So that is the average fixed cost curve. Now, this should be bringing up some thoughts for you about volume. What does it say? What does it speak to you about volume for some companies? Give me a story or something that this talks about where volume would be important for some companies. When would volume be important? Volume of production, right? I'm talking about the scale of production. When would that be important? Let me go online. I want to make sure Brianna jumped in there on that last one. Let me get one of you guys here. So when would volume be important to a company, given what we just did here, where, gosh, you produce 100 units, it's 13,000. Of course, 1,000 units would bring that even down to 1,300. We're bringing it down. When is volume important to a company? When we think about average or fixed cost versus variable cost, when is volume important? Let me stick online. Brianna, give me a number between 3 and 8.
7.
7. 1, 2, 3, 4, 5, 6, 7. Stormy, you're a lucky winner. Yep, I can hear you.
Okay, so the question is, when is volume important?
Yeah. For a company, when we've got this thing going on here, the red line is dropping like a rock. You know, what type of company is volume important?
What type of company is that?
Yeah, like, and I'm talking, when I say type of company, I'm not looking you to go to, you know, Silicon Valley or healthcare or whatever. I'm talking the ratio of fixed cost to variable cost. Like, think about that company being, are you fat, is it 80%, 20%, or 80%, 20%? When is volume more important in terms of the ratio of fixed cost to variable cost? You got a lot of fixed cost or a little fixed cost?
A lot.
A lot, right? So if you have a lot of fixed cost, in order to make total costs small, you'd want to make a lot of product, right? Once we start to get out to 1,000, how about 1 million? Remember, if we make 1.3 million of these suckers, what's the average fixed cost? $1, right? So making volume is important in that situation where there's a lot of fixed costs. So that's where this decision will be, you know, appropriately choosing the size of your factory, the size of the loan you might be getting, right? If you're starting a new business, should I buy a really big building with a lot of land, or should I start smaller? You know, how big is my market going to be? In order to make these, if I think I can sell these things for $5 at Walmart, then I better bring my fixed cost. I need to be making like 1.3 million. Is that a reasonable estimate? That's some of the things we're going to be talking about today, is like, is that a reasonable amount of these things to be making 1.3 million? Or am I just being dumb, trying to think that I think the most I can sell is 500,000 of these things, right? Well, if it's 500,000, that's going to make a big difference on the bottom line. If you're only making 500,000 versus making 1.3 million, where it's only $1. Okay, any questions or comments there? All right. So, what about these other ones then? So that was fixed cost analysis. The one we typically look at is this picture. And so what I'm going to ask you to do is kind of watch me and record this in your notes accordingly. And just trust me, and we're going to kind of work backwards of why it looks the way it does. So the average total cost is kind of a bowl shape. This is getting back, JC was remembering this graph. So this is the one JC was thinking of before. So the average total cost curve looks like a bowl. Now, what does that mean? It means that at low levels of production, I have my average costs are going down as I produce more, similar to this picture. But eventually I get to a point where my average total costs are starting to go up, right? So they're starting to climb on average is what this bowl means, which means there is some point on your picture, go ahead and draw a big fat dot, where the average total cost is minimized, right? So the minimum point is at some point in your graph, just draw a big fat dot there. That's where average total cost is minimized. For some type of problems, we might be looking to minimize costs, right? And so if you were asked a question, where are costs minimized? The answer would be at this point, this quantity here, where it goes through the dot. Maybe it's at 100 units. I'm not connecting this to this picture at all, by the way. So average total cost is minimized at the production levels of these gizmos, or maybe I better switch to mice or something here to not confuse things, of 100. All right, and then the average variable cost curve is also bowl-shaped, but it lies to the left. The minimum point lies to the left. So watch how I graph this. There's another detail that I haven't even told you about yet. So watch this, everybody watch. We're gonna go down and bowl, and then we're gonna approach the average total cost curve. So the vertical distance is shrinking, and this is a real important point. So it's shrinking as you go up. So the average variable cost curve looks something like that. So make sure that that variable cost is vertically shrinking as it approaches the average total cost curve. And then it too has some sort of minimum point. Looks like mine is going to bottom out here at 70. It doesn't matter whatever numbers you have there. We don't even have to put numbers. I could have put Q1 and Q2 or something. So that's where average variable costs are minimized. Both of these points are important in different respects that we'll get into later. But that's the shape of this. Okay. Now, why does it look the way it does? That's a loaded question. So these things look this way because of the relationships at the margin of additional costs that enter, which we haven't even talked about. So this is the relationship of the averages, but for the most part, average costs don't belong in decision making. So I'm kind of teasing you a little bit by bringing up the averages first, when really economics is, the economic decisions are made at the margin. What is the incremental cost associated with moving from status quo to another direction? That's what we're thinking about with marginal cost. And so the formula for marginal cost is the change in total cost from the change in quantity. If I'm currently making 1.3 million gizmos, what's the cost of making just one more, right? That's what I'm looking at. What is the cost of one more? If I crank one more off the production line today, what is the incremental cost? So marginal cost is the change in total cost divided by the change in quantity, or to put it in words, let's just write in here the cost of an additional unit of production. The cost of an additional unit of production. All right, so I like to bring up my example. Some of you have had me before, which is a handful of you. You'll hopefully remember this fondly. But I used to work at a Greasy Spoon restaurant starting at age 15. And so I have fond memories of working the line with Schmitty and Mike Smith and Jack Benjamin. So we had a lot of people up there. And so I want you to imagine that this tabletop is the grill at the old restaurant. And so I am in the business of making hamburgers. And so we can analyze the cost of hamburgers, the cost of labor, all the normal things going in with the restaurant. And so what I want to think about is I can make 100 hamburgers by myself on a shift, whatever that unit of time is. So could be 1 hour, could be longer, it doesn't really matter for this. So I can make 100 hamburgers. So Russ is pretty good at making hamburgers, and so I can make 100. My question to you is that if I add an additional Russ, an additional person, will the two of us be able to make 200? More than 200 or less than 200? So Russ can make 100 hamburgers all by himself, and I am going to add an additional Russ to the production process. Will we now make 200? More than 200 or less than 200?
Less.
Less. All right, let's go to the chat box on this, you guys online. So if everybody can respond in the chat box, 100, more than 100, or less than 100 on the chat box. And what are you guys thinking in here? Depends. More? Think you can do more? Why are you saying more?
Well, why can't make so much? Why can't you make more?
What would cause them to make more?
More hands.
More hands. Okay, what would those hands be doing differently?
Or sharing
So-
the load.
So let me be clear, since this is economics class, we can have fun with assumptions. When I said an additional RUS, I meant a cloned RUS. So the extra RUS is equally productive and identical to the first RUS, right? So I'm not bringing in superstar RUS versus loser RUS. Loser RUS can do 100 and superstar RUS can do things that loser RUS can't. I got identical RUSs. So with this thought experiment, that's kind of important. Jonathan?
More because of specialization.
More because of specialization. What do you mean by specialization?
Because one of us can be specialized in one aspect of making burgers.
Okay.
And the other one is specialized in that also increases the production.
Okay. So on the chat box, just to kind of bring you guys in here, we got less than 200 because space is limited, less. Wow, you guys are almost unanimous. Less than 200. And Jonathan, you're saying what, more or less? More? Okay, through specialization. And you said that maybe one RUS can patty up the burgers and another RUS can prepare the buns. Does that sound like in the real world something that's possible? That you guys specialize in certain tasks and that way you could do better with two than you could with one, or if each RUS is operating individually? Another thing to think about with this thought experiment is that if we have one RUS make 100 and then the next RUS all by himself could do 100, can the two jointly do more or less? Let me see. Okay, so Brianna, you were bringing up space is limited. Okay, why don't you unmute and give that? I think that's a good comment.
Well, you just said you were hiring another person. You didn't say that you were getting more equipment. So I assume that if one person can only do 100, I didn't know if that.
No, I think your comment is totally spot on. So, you know, is there enough grill space, right? So when I was operating the grill, did RUS number one pretty much only use half the grill or a third of the grill space, right? So in other words, the grill had excess capacity to be able to fill up so that an extra RUS had room to do their thing too. So that's definitely a valid comment on whether you'd be able to increase or decrease. Okay, anybody else? JC?
That brings in the topic of marginal diminishing product, because if you add more RUSs and you don't have enough space, then you're going to get to a certain point that it's going to start decreasing.
Okay, so yeah, once we get to the space, is that going to change, right? So we want to think about that. So are you guys okay online then? If it's possible, if we do have, taking Brianna's comment into account and assuming it away like good economists do, we'll just say we have excess capacity at this point, that the grill has extra, that the two of us combined could make maybe 220, right? We could make more. Through specialization, as Jonathan said, I patty up the burgers, RUS number one, RUS number two, grills the buns and does the plate sets. And by us acting together through specialization, we could potentially do 220. Okay, what if we add RUS number three? RUS number three, do we go from 220 to 440, more than 440, or less than 440?
Are we still talking about excess space?
That's what we need to be thinking about, yes. Do you think it's reasonable that we would hit that yet or not?
Well, I think that's what the answer would completely hinge on. I mean,
Okay.
if you've got extra space, then yeah, you can get more, but if you don't, then you're absolutely not going to get more.
Okay. And maybe beyond that though, is there room for further specialization? Is burger making complex enough that we could distribute the tasks to 3 different things, right? So now somebody's completely doing this. Of course, we didn't talk about, is this a California burger? Do we got tomato? Are we slicing tomatoes and doing lettuce setups, right? So we're leaving a lot of blanks out here. But that's why I wanted to get you guys thinking about this stuff, of the things that would enter the equation that would change the result. And so it's possible that 3 RUSs with this grill space, and I am identifying, you guys can't quite see this online, but this is my grill right here. It's kind of a, oh jeez. And they built that pretty sturdy here at Ottawa University. Good quality equipment. Okay, so we do have a fixed grill space. If there's excess capacity, if there's room for specialization, maybe we could increase again. But now we keep going. Rust number 4, rust number 7, rust number 8, rust number 16, rust number 23, rust number 31. 31 russes around this grill.
And one grill.
What's happening to productivity at the margin? How many hamburgers is happening with the extra rust? It's going down fast. In fact, seriously, if we take this example the way I'm purposely doing it this way, does the 31st rust add any hamburgers? No. In fact, the 31st rust might be taking away from rust number 3 and 4 and 7 and say, hey, what are you doing this weekend? Maybe we could hook up and I got some cool place we could go or something, and they're distracting the other russes or something. So eventually, extra russes bring nothing to the table when we have at least one resource fixed. And that is the most important part of the story. That is the law of diminishing marginal product, or also called the law of diminishing returns. Okay, so let's write that out. The law of diminishing marginal product. So marginal product would be like MP, and we're talking about labor here. We also call this the law of diminishing returns, like the returns that I'm getting from extra russes. So you can kind of use those interchangeably. The law of diminishing marginal product. And it goes something like this. As you add more and more of a variable resource, in my example it was labor, more russes. As you add more and more of a variable resource to at least one fixed resource, as you add more and more of a variable resource like labor to at least one fixed resource, that was our capital, the grill in our example. As you add more and more of a variable resource to at least one fixed resource, the product associated with the additional labor, or the variable resource, eventually falls or diminishes. The law of diminishing marginal product. You're always going to bump into this constraint in the short run, which is another distinction we'll make here in a little bit. In the long run, I can buy another grill. But this week, I'm stuck with this grill, right? This week, I'm stuck with this rent or this building. But give me another year, I can move into another building, I can build another grill, I can increase my grill space, whatever. So that's what we mean by variable and fixed costs there. Okay, any questions or comments there? All right, well, let's get a few more numbers going here. I'm probably going to regret erasing that picture. We'll come back to it though. Okay, so all I've done so far is looked at a physical relationship between inputs and outputs, right? Inputs being rusts and grills, and output being hamburgers. That's like an engineering relationship, right? So all I've done is looked at the physical connection between inputs and outputs of whatever that process looks like. So where did the cost come in? So let's do labor, and let's go at 0 russes, 1 rust, 2 rusts, 3 rusts, 4 russes, 5 russes. And then let's look at, we're going to do about, by the way, leave enough room on your paper, we'll have about 6 columns of data here. We're going to build out a little table. So labor, and then hamburgers. So with 0 Russes, I can't have any hamburgers. 1 Russ gives me 100. 2 Russes, I can bump up to 220. 3 Russes, 320. 4 Russes, 400. And 5 Russes, 460. So there's our production function showing the relationship between variable resource labor and our output hamburgers. So what we were looking at then was the marginal product of labor, the marginal product of Russes. And so what we're doing is incrementally seeing what each additional Russ brings to the table in terms of production. So 1 Russ gave me 100 hamburgers. So the marginal product is the change in quantity from the change in labor. So from a formula standpoint, marginal product of labor is the change in hamburgers from an additional change in labor. It's written that way. With this example, I'm just going from 1 Russ to 2 Russ to 3 Russ to 4 Russ. I could go from 10 to 20 to 30. You might see some other problems in your homework that would just bump up by tens. And then we're just kind of averaging the incremental bump from the data that we have. Okay, so then what is the marginal product of the second Russ? 120. So by adding the second Russ, that Russ makes me 120 hamburgers. Now wait a second, I thought they were identical Russes. What is it, Luke?
Specialization.
Specialization. So is it possible that they are clones of each other and we still get this result? Yes, because of the specialization. That's important to point out that the production process has changed, right? When 1 Russ did it all by himself, he had to do everything. And so it's a fundamental change to allow specialization to occur. And this is what Adam Smith brought up in 1776 in The Nature and Causes of the Wealth of Nations, is that by coordinating behavior in the production process through specialization, there can be tremendous gains to production in terms of the benefits. So we can add an extra Russ and get that much more hamburger, even if it's identical. All right, so then marginal product of the third Russ, we go up by 100, right, from 220 to 320. The extra 4th Russ is only 80 now. Specialization benefits are starting to go down. We're starting to bump into each other on the grill, right? A little bit of congestion. We can't operate as freely. The grill space is starting to be limited. And then finally, we end with 60. Okay, questions on how we derive these numbers? This is kind of undefined here, by the way, a marginal product of 0, so we don't have any. Okay, so how about the average products? The average product of labor is the total quantity being produced divided by the labor being used to produce it. So the average product of labor, if I have 100 hamburgers and 1 Russ, then on average, each Russ is producing 100. What's the average product when I have 2 Russes? What's the average product? 110, right? So all we're doing is we're saying we're making 220 from what? I've got 2 people. 220 divided by 2 is 110. So the average product here is 220 divided by 2 equals 110. What's the average product here of 3? Starting to get a little dicey here. We got 106.666 or something, right? So 106.66, 0.67. We won't worry about some fractional hamburgers here. 4 people, average product, 100. And then finally, with 5, 92. Okay, so why is this important? Okay, so now you're a manager at Whataburger, which I'm totally excited is here in Kansas City. Thank you, Patrick Mahomes, for all you do on the football field. But I'm especially thankful for bringing Whataburger to Kansas City area. So I'm a big Whataburger fan. Haven't eaten there yet. It just opened a couple weeks ago, I think, near the Legends Mall. All right, so why is this important? So suppose that we are currently at 320, and all of a sudden the phone rings and they say, hey, we've got a big party going on and we'd like to get 100 hamburgers, right? We'd like to get 100 hamburgers. And so the manager's looking at this and they're like, oh, that's no problem. We'll just get another Russ to come in. I'm sure he's available. He's probably just sitting on his couch watching Netflix, binging, or doing, Russ doesn't really do video games that much, but so he's probably up to nothing. So yeah, we'll get him to come in. And so why are we calling the next Russ in? Because the average product is 100, right? No problem. I'll just bring in another Russ and we'll meet that order. But what problem is the manager going to run into when we hire the extra Russ, the fourth Russ, to come in to fill the 100 hamburger order? We're only going to make 80, right? We're going to come up short. So don't look at the average. Most managers, by the way, look at the averages. If you guys start to sit in on some boardroom discussions or maybe even some of your GA duties, maybe you're looking at average scholarship per person or average this or that, and that actually kills me because we think about the discount rate here at Ottawa with the tuition, right? And so we have students that are on scholarships at various levels, and so we're like, oh, well, I gotta bring the average down. We're looking at the average, and it's like, if you need an extra kid, you need an extra kid. What is the marginal student going to cost you, right? So does the marginal student, if I have a soccer team with a roster of 15 currently, what's the 16th recruit going to bring in terms of the benefits? You know, what are their skill set, blah, blah, blah. And then what are their costs? You know, if that student has other opportunities to go play for a couple other colleges, yes, it might bring up the discount rate or bring up your average, and you might get in trouble with Arabi or have to explain yourself to Dr. Satsui or something down the road. But you could make a compelling argument that we're going to win with this kid, and he's academically strong, so our academic scorecard is going to go up, right? And so you start making an argument that let's not look at the averages, but what does that person bring in at the margin, right? So it's always at the margin. Where are we at? And who are we adding, and what are they going to do for us? Okay, so questions or comments here on this? All right, still haven't talked about dollars yet, right? We still haven't talked about dollars, so we need to bring dollars into the picture here. So let's talk about the price of Russes and the price of maybe some costs, some fixed costs. So let's say that our total fixed cost is 100. So if I produce 0 hamburgers, what is my fixed cost? 100. What if I do 100 hamburgers? 100. 100, 100, 100, 100. That's why they're fixed costs. So when we did it graphically, it was the straight line earlier. Now with our schedule goggles on, we call this kind of a schedule of numbers. Then it's just going to be the same number all the way down. So sometimes on your homework or test, you might have kind of a fill-in-the-blank thing here, and this will be the one that's missing inevitably, like, oh my gosh, what is it, what is it? Oh, well, at 0, we still have our fixed cost. That must be 100. So even if we don't have any hamburgers being produced, we still got to pay the rent. All right, so let's say that we can pick up a Russ for 10 bucks. So let's say the wage is $10 an hour for a 10-hour shift, just to keep the numbers easy. So this is the total variable cost. So if I produce 0 hamburgers and have 0 Russes, I don't have any variable costs. 1 Russ is going to run me 100 bucks. What's 2 Russes going to run if I want to ramp up production to 220? 200 bucks. So now I can pick up Russes. You know, we equal pay for equal work. Okay, well, not only that, but we have a cloned Russ. So let's just pay Russ the same amount each time. So I can pay 100 each time, which means my variable costs are climbing by $100 for each rust that I add. All right, so then what's my total cost? Total cost of producing 0 hamburgers? 100. 100 hamburgers? 200. And now we see we're just adding that extra rust cost, so it's 300, 400, 500, and finally 600. All right, so the reason I'm teeing this up the way I am is that a lot of times it's confusing for people of, well, why do marginal costs get so expensive? When I can buy hamburger at $4 a pound, buns are $5 for a 12-pack, right? Pickles are $5 a jar. I can hire Russes at $10 an hour. All of my costs are linear in terms of what I put into that hamburger. So why do marginal costs change for the hamburger? Why do they take on the look that they do when it seems like I should just be able to produce as many as I want? And the answer starts to jump out of us here as we move into the next few calculations. So notice that my total costs are changing each time by 100. When I go from 0 hamburgers to 100 hamburgers, the change in total cost is 100. When I move from 1 rust to 2 russes and 100 to 220, my change is 100. My change is 100. In other words, a pound of burger, the package of buns, the rust per hour, all of that is changing at a similar amount each time with each additional rust. But what was our marginal cost equation? Our final equation over here. I just gave it to you earlier. Hopefully you wrote it down. What was the marginal cost equation? Change in total cost, which is this column, by the way, divided by the change in quantity, which is this column. The change in quantity, because we were adding an additional rust each time, is actually this one. So the marginal product for this particular problem, because I went up by 1 each time, are these numbers. And so now, those of you with a calculator out, the change in total cost over the change in the amount of labor I'm hiring each time. So the marginal cost of the first 100 hamburgers is 100 divided by 1 equals 100. Is this the change in labor or the change in quantity? Quantity. So 100 divided by 100, each hamburger is $1. So the cost incrementally of those first 100 hamburgers is $1 each. What about at this level of production with 2 russes? What is the marginal cost of each additional hamburger? Those of you with a calculator. We got 100, the change in total cost, divided by the 120 new hamburgers that the second rust brought to the table. What is the cost of each additional hamburger, Jack? So you got a calculator.
It is
0.83. 0.83. So 83 cents a hamburger. So the cost of hamburgers went down. Why? What drove that result? That it was $1 per burger up here. We added $100, and now they're only 83 cents. Jonathan?
Made a marginal decrease in labor.
Okay, so the marginal product of labor, right? So now I think about it this way. Does this make sense? I picked up an extra rust for $100, but this rust made 120 hamburgers. Is that a good rust to buy? buy his labor? Yeah, right? That was a deal, right? That was a really good deal. And so at the margin, those extra hamburgers were only 83 cents when I hired the second Russ, because that Russ was more productive, still identical, more productive because of specialization of labor. All right, let's move on then. What do we got for marginal product with 3? Now we're back to 100 divided by 100. We're back to a buck. 100 divided by our 80. $1.25. And then finally 100 divided by the 5th Russ. What's each one of those hamburgers running? $1.67. $1.67. Hamburgers are going up in price. Why? Why is each additional hamburger getting more expensive for my company? What law? Yes. So now that the Russes are bumping into each other, those hamburgers are getting more expensive. I need to know that. So is it a good thing for me to run a sale of $1.50 when I was currently at this production level? No, you'd be kind of dumb, because each hamburger is going to run you $1.67 because of the law of diminishing marginal product kicking in, right? So that's why looking at the margin is one of the top principles of economics. So this all falls under the area of marginal analysis. All right, questions or comments there? Online, I haven't given you guys a glance here recently, so thumbs up if you're all right with that. Okay, any questions? All right. All right, so let me go back. You guys can just use your picture that you had before, the one I erased, so I'm going to draw mine quickly. So we had the average total cost with the minimum point, average variable cost with the minimum point, and now we're going to complete this picture. The marginal cost curve is J-shaped and cuts through the minimum point of both of those curves. So go ahead and draw that in. It's J-shaped. It bottoms out to the left of this other point, by the way. So it's J-shaped and escalates, cutting through those minimum points. And the reason it does is what we just went through. If we go back to the schedule of numbers, that's this J shape, right? $1.83, $1, $1.25, $1.67. So it's coming down for a little bit early on, and then it's shooting up. So we have increasing returns to labor with the early Russes. There's some low-hanging fruit, like definitely hire those Russes, right? But then diminishing returns kicks in. Now, it's not to say that we shouldn't hire the 5th Russ. Can anybody give me a reason to hire the 5th Russ down here of that lowly loser Russ only bringing in 60 hamburgers?
If you're selling hamburgers for $2 a piece.
Okay, so so now we have to bring in the other part of the equation, right? And that's where we're heading tonight, is to look at the benefits relevant to the costs, related to the costs. Which one, how do those weigh out with each other? And so we might be at 6 or 7 or 8 Russes, right? We don't know until we have more to this part, but all we're trying to dissect right now is this relationship of the marginal and the averages. So another way to highlight the marginal and the average is to think about your GPAs. So you come to Ottawa University, maybe this is true for some of you, your freshman year, and you were pretty good in high school, and so you came in all full of thunder, and so you got a 3.0, not bad, not good, whatever, decent B student. You got a 3.0 your freshman year. Of course, you met a lot of friends, and now your sophomore year, fall semester, you start doing a little drinking, little pot smoking, little, having fun, skipping class. And so you end up getting a 2.0 fall semester sophomore year. What happens to your GPA? Does it fall to a 2.0 when you had a 3.0 your freshman year? No, it's going to fall, right? But it's not going to fall to a 2.0. Your marginal grades are less than your average, so it's bringing your average down, but it's not going to go all the way to a 2.0. So let's just say it falls to 2.7. So now your parents have yelled at you, you're even thinking, maybe I should start to get my act together. So you do, and you get a 2.7 spring semester, sophomore year. So your overall GPA had fallen to a 2.7, and you got a 2.7 your spring semester, sophomore year. What happens to your overall? The overall was 2.7, and you got a 2.7. It stays the same, right? So your marginal grades had no impact on your overall average for that term. So then you're coming into your junior year, and you're thinking, oh, I want to get an internship and get my life together, and blah, blah, blah. And so fall semester, junior year, 4.0. All bullets all across the board, all A's, 4.0. Does your GPA now rise from 2.7 to 4.0? No, because you still have 2 years plus under your belt, but it is going to go up, right? It's going to go up by some amount. That's what's happening right here. So when the marginal hamburger is less than the average hamburger in terms of cost, when it's less, then it's going to be pulling the average down, right? So you're going to be pulling the average down when your marginal cost is less than your average total cost. Then, when your marginal cost is equal to your average, they're the same. That's this intersection point. And then as you continue to produce, those hamburgers are getting pretty expensive due to the law of diminishing marginal product. Those additional hamburgers are now $1.67, and that's going to start to bring up your average total cost. So that GPA example is the same thing that's going on in business when we're analyzing cost at the margin versus cost of overall, your average cost, both marginal and average total and average variable. Okay, so questions or comments there? All right. So let's see. Let's bring in. Well, we got to get to our break here in a second, so I'm going to be careful I don't get too far. We'll have a break here in, I don't know, maybe 5 to 10 minutes. But okay, so what about the other side of the equation? What's our profit equation? So for this class, I think I did this last time, I used the pi sign. In macro class, it's inflation, which is a whole other topic we won't talk too much about in this class, even though it's very relevant. But my profit, what's the profit equation? Total revenue minus total cost. So we've been focusing in on variable costs and fixed costs, but it's total revenue minus total cost. And what is the total revenue equation? Price times quantity. And what is the total cost, if we think about it similar to price? How could we express the total cost formula here?
Cost times quantity, variable cost.
Not cost, but it is times quantity, but what times quantity? So we're kind of mimicking this. What goes there to give us total cost?
Variable cost?
Yes, very good. See, that's the advantage of sitting up close to class. You can read lips better. So yes, average total cost. So check it out. The reason we do this is that it's kind of nice for decision making to look at price versus average total cost, right? Because you can immediately start to think, am I making money overall? What is my total profits? If my price is greater than my average total cost, then I'm making some money, right? So that's further highlighted by what can I do with this equation to make it a little more simplified with these Q's. Who's got their math cap on from algebra days way, way long ago? What can we do with those Q's, Jonathan?
Multiply them out or divide them out.
Divide them out, but I don't actually want to divide them out because then I got to bring them over here. But we're just going to factor them out. Yeah, so this can be looked at as this. The difference between price and average total cost per unit, price per unit average cost per unit. So I'm selling my gizmos for $5, and my average total cost, let's say, is $2. $5 minus $2 is $3. I'm making $3 per unit on average, and I'm making 1.3 million of them. That would give you your total profits of making these things. Yes? Good? Yes? 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 Let me hear a yes.
Yes.
All right, beautiful. All right, so that is our profit equation. So where do we piece this together now to make a good decision? So here's the balancing act that we're doing, as we talked about earlier. So our marginal cost is the changes going on as I make more hamburgers. So let's go and look at that for a second here. Total cost equals total variable cost plus total fixed cost. And we said that marginal cost was the change in total cost divided by the change in quantity, right? So I'm kind of doing this a little bit backwards, so I apologize. But that's what this formula is saying here. How much do my costs go up by when I make one more unit? So now we can do a little more math working this direction with it. Oh, okay, well I have a triangle Q here and a triangle there, so the change in variable cost over the change in quantity and the change in fixed cost over the change in quantity is another way to express this equation. Does that look fair so far? Now, this can be simplified. So this is saying that the marginal cost, the cost of an additional hamburger, is equal to the change in variable cost from producing more hamburgers and the change in fixed cost from producing more hamburgers. How can we simplify that equation? And chat box, I'm looking at you. If you're seeing that, how can we make this chunk here a little easier? It can be really greatly simplified. Jonathan?
Change in total cost divided by change in quantity.
No. Because we have that here. If I'm here, you said change in total cost over change in quantity. So this is equal to this, so I'm not looking to do that. But there's something special here that this can be broke down more. So let me hang on my words for a second here. You guys got the whole rent thing, right? We started off, you got rent for the building, and well, we don't want to talk about rent because we're talking about changing, the amount of basketballs or the amount of burgers. So marginal cost, hang with me, is the change in variable cost from making more hamburgers plus the change in fixed cost from making more hamburgers.
There's no change in fixed cost.
There's no change in fixed costs. It goes away. Right? Fixed costs don't change when you make more hamburgers. Fixed costs don't change when you make more gizmos. Fixed costs don't change when you make more basketballs. So when we look at variable cost, when we look at marginal cost, we're actually only focusing in on variable cost because those are the only things that change, right? Those are the only things under my control as a manager at the grocery store when I'm trying to decide, should I cut one of my 10 people checking people out or not, right? Is that a good move or not a good move? My rent's gonna stay the same, so that doesn't belong in this equation, only the variable cost. Okay, and so then what I wanna leave you with as we move into our break is this side of the equation. If I produce another hamburger, how much am I going to be able to get for it? So marginal revenue, MR, is the change in total revenue from an additional unit of production. From a formula standpoint, marginal revenue is equal to the change in total revenue over the change in quantity. Okay, so now we have our balancing act going correctly. So when I'm back to my hamburgers here, this hamburger, the 460th hamburger, the 455th, or these extra 60 hamburgers, each are costing me about $1.67. How much revenue would I need to be getting to justify making those extra 60 hamburgers? How much revenue would I need to generate per unit? What would I need to do? So each hamburger is running me $1.67. By the way, remember, these hamburgers are identical to the ones that were 83 cents up here. That's what's a little fuzzy, so we're kind of wrap your brain around. It's not like these are the double hamburgers with cheese and these are the single hamburgers, right? These are all the same hamburgers. It's just the production process and the relationship of variable costs and fixed costs that are changing as we move through production. So, in order to make these extra 60 hamburgers, what would I need to generate per unit? At least $1.67, right? So something greater than $1.67. So that's what we're going to do here with our marginal revenue, is how much additional money in the cash register do I get from these additional 60 burgers? Am I going to sell them? Am I not, right? And so what's it usually going to boil down to is the price. Now, how many of you have been to, usually it'd be something like a high school or maybe even an OU game where they're doing hot dogs, right? What do they do in the third quarter of the basketball game? Or the second half, the last quarter of the football game? Football is where I've seen it the most.
They do it for free.
They do it for free?
Or they say $1.
Yeah, $1, right? That's what I was looking for. So you guys been at the football games where they're walking around, and had you bought one during the first half, they're $2 or maybe even more, $2.50 for a hot dog. And now we got people walking around like, hot dogs at $1, hot dogs $1, right? And so at the margin, what are those cooked hot dogs in the bun, wrapped up, sitting in the warmer? What's the marginal cost of those burgers, of those hot dogs, sorry? How much? Why? I disagree with you.
That's extra, ain't it?
So I want you guys to be real. Put yourself in that concession stand. How many of you have done this? That you've made those hot dogs, popped that popcorn, right? What is the marginal cost of those hot dogs? Remember, hang on to my words here. The hot dogs are cooked, they're in the bun, they're wrapped. They're just sitting in the heat warmer, and it's the fourth quarter with 10 minutes left. What is the marginal cost? And we have volunteer labor. Zero. So what's the profit at the margin when I go throw them out to people for $1? $1. We're making $1. You have to train yourself to think that way, because it's too easy to wrap in the rent into those hot dogs, right? But truly, the incremental cost is taking a person out to the stands. That's why I threw in the volunteer labor for fun, right? You guys are volunteering to raise money for your club or something. And so the labor's free. They're just sitting there. Where are they going to go? 40 hot dogs. That's going to be where they end up, right? Maybe they go to the homeless shelter or something else. We can think about other opportunities there. But if you're trying to raise money for your club, selling them for $1 is a pretty good idea. Now, what's the problem with that potentially? If you're a savvy football game goer and you're kind of hungry, third quarter, 5 minutes left, you wait. You know they're coming by with the $1 hot dogs. Now, are you taking a risk? Is it possible that they've sold out of hot dogs? Or you're at the left side of the stadium and the hot dog dudes start at the right side of the stadium and they do $1 hot dogs and they get halfway through the stands and you're like, oh, we're out. Oh, God. right? So you're taking on a little bit of risk, and so you have to be careful with those sorts of setups that you're not lowering everything. Because if everybody was thinking that way, nobody buys a hot dog until the fourth quarter. And then what have you effectively done to this equation? What are all your hot dogs selling for? $1. And now you didn't do that as good as you were thinking. And now the next football game, you're like, well, maybe we shouldn't do that, or we won't make as many hot dogs, right? And so now you're adjusting your production levels from game to game or week to week, depending on the circumstances.
So say it was instead of a hot dog, brats was like $2.50, and they say they changed it to $2.
Yeah.
Or something like that. So would that still count as throwing away like what they?
It's the same thing. So each time, yeah. So whatever it is, brats, hot dogs, or anything, if the alternative is to get thrown away and the marginal cost is basically zero, then anything we can get for these dogs. But some of the points I wanted to bring up was that maybe that's bad for long-term decisions. Do some companies not do that with the hot dogs, and they actually do hit the garbage can? Yes, right? So, and sometimes we've gotten a little bit away, like, oh, well, we can give it to the homeless shelter. That's kind of why I brought up the homeless shelter thing. It's like, oh, we'll help feed the hungry and all that. And so they're thinking, homeless person is not coming to Panera Bread for lunch and dinner, right? So I've got maybe a nice separation that it's not the same crowd. Whereas at the football game, it's the fans, and they would be buying those same hot dogs. They're either going to wait till the end of the fourth quarter or get them in the first 3 quarters, right? And so that's the same clientele. So we'll get into kind of sophisticated, it's called price discrimination. That turns out to be a good thing. So that's kind of the exciting thing. I know discrimination, that's bad in today's world. But it actually turns out to be really good, and it turns out to help the poor. So anyway, we will call a break there and pick up here. Let's just call it quarter 2. We'll come back quarter to the hour and pick up from there. Okay, come on up, anybody that was late. Kim, when did you join?
Got here 7:18-ish.
Okay, perfect. All right. So I'm going to share a screen with you, and you've got basically about 5 minutes to take this and send it to me. And same thing with you. I put it in the chat box, my email, by the way, so no, don't worry about that. Yeah. Go ahead, and I'm just going to go ahead and put it up.
Oh, they're going for the break. I was like, right at Kim.
Okay, Kim, so there you go. It's just those 5 questions.
Okay.
And then same thing for you. Here, just sit down. Why don't you sit over there?
Do I need to write on my
No,
paper?
just write on that. Yep. Put your first name, last name. Question?
Yeah, I was just gonna come talk to you about like online. I was added Thursday and Friday.
Okay.
And Blackboard just showed up like within my Blackboard, like the board just showed up this morning.
Okay.
So do I accept anything?
Yeah. So the syllabus is online. Have you looked at that?
Yes.
Okay. Did you get into MindTap?
I think I'm on it right now.
Okay, that's the thing that has all your homework and tests and all of that. So that's the main thing. If you got those 2 things, then kind of read through. Those are going to be due every week. You're in the ground section, so don't worry about like discussion boards. Those are for the online sections. But if you felt comfortable digging into MindTap, each week there's different types of assessments, different types of questions. Make sure you go through all my announcements that I made about formative and summative questions. And then there's these weekly tests. So, how come you're late adding?
Because I didn't know about the math requirement. I didn't know about it, like the NBA math thing.
Okay.
So I had to get it done within like 3 or 4 days.
Okay.
To try and catch
So you, okay, so you got it, but you got that under your belt. All right. Well, yeah, we got plenty of points left in the course, but there's some of the stuff that's late, some of it you can't do late. But I won't let those points, they're relatively small to the overall points. So get in there and do those when you can this week, or did you already do them? Did you do some of them?
No, I just,
okay. So you've got basically 2 weeks worth of work to catch up on what we're doing this week and done last week. Okay? And then just shoot me an email if you have any questions. Are you officially in or not?
No.
Okay.
Like I emailed Bruce earlier today, still didn't get back to me.
Okay. So what's the holdup though?
He messaged
I mean, did you pass it or not?
Yeah, I did. Like I passed and everything. He said that he was having a hard time to register to get me in.
Okay. You got to push hard, man.
Yeah.
I don't know what to tell you. You're an athlete. Go, go, go. You go. That's your offense, defense. You're on offense.
Yeah.
You need to get in. You need to be sitting at their door and sending multiple emails. Don't rely on Bruce. You can go straight to the registrar. You saw I copied you in on an email, I think, about getting it done. So chase that down.
Okay.
If you truly passed it and it's just some bureaucratic thing of pushing a few buttons, you got to push it and get it because you need to be in there like tomorrow.
Yeah. Okay.
Okay.
All right.
Because that's the only way you can get access to the content that we need to do. Yeah, you need to get on. Yeah, you were already late on some stuff, so.
And then I would have came last week, but he said that I couldn't because I didn't come.
I know. Yeah, I told him about that. Yeah, especially if it's down to sounds like a technicality, but you need to chase it down if it's just a technicality. So, okay, it's on your shoulders. Get it done. You can do it.
Password. Username. Boom.
You know what I don't understand? We don't have this weekend over. Because it's like the next one, the section 2 is due July 17th.
No, we do have some. We're still in section 1 right now, so we're still chapter 4 and 5.
Oh, I already did that.
Chapter 1, 2, 3 was for last week. Chapter 4 and 5 is for this week.
Oh, you did them all already? Yeah. Because I thought it was a section 1. Oh, yeah.
I have my discussion this week tonight, but I'm struggling.
I was thinking Tom was doing oh my God, yeah. Oh no, yeah, me too. How am I not thinking like did the exact same questions except for the one word in the gym, every word changed and how I answered. You see, come here. For these things, I used to do instead of 5%, 8, and instead of 100. Just do it.
$1 times 100 times 1 plus 8 cents.
5, Joe. It's 8. No, I mean in the result, I want all decimals.
That is all decimals. do the discussion first. Just do the discussion first.
Professor McCullough,
He's not here.
Yes.
he's not, I don't know where to go to get my answer in. I don't know how to get it.
He's not here right now. What is it you need help with?
All right, okay, thank you.
I need your brain to tell me with a smartphone on this. It's work.
Are you taking working capital, sir?
You look the prime. I just saw this consequence. I have no reason.
We're gonna pass you on.
We're gonna have to look at the first tomorrow. It's like that straight. Then I come back on the every teacher probably on the
No.
No, what do you mean by that? How many lines? No. Which
I tried and I thought I was gonna like keep going, but I still can't.
Well, you gotta make it fire. So it's
I'm not inspired.
Don't worry, you're not going on the phone screen.
Struggling, bro. Struggling, phone sleep.
I step out.
It's like warming there. It's making a little bit more sense this time.
That's why I take long to put on this inspired.
Yeah, I was embarrassed because I was looking at the one part. I thought the first part, I was like, oh, people let it. This was all bad. It was only good sleep.
I get it. I gotta. He's like, hang on my word. I'm like, oh, I am. If I wasn't, I'd have no clue what's going on.
Tell
he said, don't worry, I give you the direction.
Amazon something, machine learns your habit, mind habits, and then he suggests what's hard is this? Yes. What uses this?
It really is. I was thinking,
someone on the platform will zoom to the office.
I guess one of the questions on the homework, the brushing up on your math skills, because I didn't pay attention to the scale on one of the graphs.
Yeah.
What's your
question?
Oh.
Or you're just making a comment?
I just made a comment, and I paid attention to the scale of the graph. I got it right the first time, but I didn't, so I messed it up.
Let's see. Anson, you win. You there?
That's what I'll think about some people that get lost to do it. Yeah. I'll be down for it, but
Like her church or something?
yeah, that's what she said. Sure.
Exactly. It's so weird, like kids you've never met before. No, you know she's all from strangers?
No, but you
Yeah.
like sir.
Hi, Anson. Do you have a video?
Oh, sorry. How to check it?
Are you planning to use this for credit in the online class?
Yeah.
To replace the discussion? To replace the discussion? Anson? I can't.
Yeah.
Okay.
Are you hearing me?
Yeah, I can hear you. In order to have it replace this discussion, you need to have a video on so that I can see you. And Jackie, I think you go by Jackie, right? You Wing, are you there?
She should work all right.
So yeah, Anson, if you look at some of my announcements, in order to use this for the online class, you do have to have your video on the whole time so that I can see you like I see the rest of the class. And
okay. Because it's in the morning in Hong Kong, so I'm trying to point. I'm not able to open the video.
okay.
Yes, and in the other time.
You can't open it before a certain time?
Yeah.
Oh wow.
Doing travel.
Is that because of internet traffic or because of government regulation or what?
No, it's troublesome to open a video while traveling.
Oh, while traveling. Okay.
Yeah. Because I work.
I understand. Okay, so it's during your workday. Okay. Yeah, so that's one of the requirements that I have for people joining by Zoom. So if it doesn't work for you during that time, you can just do the discussion board as an option. And you're always welcome to join. So let's just say that you work for the first 2 hours, or you can only catch the second half. You're always welcome to join the class, but you won't be able to allow it to replace discussion unless you're here for the full class with your video on.
Okay.
Does that make sense?
Yeah.
Okay. And Jackie, are you there? Okay, not yet. You're here, okay. And can you turn your video on?
We are on the way of traveling to work. And put it this way, I'm almost in the office.
Okay.
It's Hong Kong at 8:45 a.m.
Okay, so you were traveling. Okay.
We need to like start the class at 7 a.m. while we're traveling, heading to work, and then we literally need to start working like real soon.
Yeah, I understand. So yeah, so did you hear my comments to Anson?
Yeah, I heard. Yeah.
Okay. Yeah, you guys are always welcome to join any part of the class if you want, but if you're not able to join fully, then you'll still have to do the discussion board online.
Right. We're working on it, but really, even we have time difference, Anson and I really want to participate as well. That
Perfect.
is why we got up really early to join the class.
Yeah. No, I'm glad you did. I'm really happy to have you join in. So I just wanted to make sure you understood everything, and as much as you can join in, and we'll have you join in on class. I love having you guys, so that's great. You missed the first week. We have people in Serbia. Jovana's in Serbia, so she's 10 hours the other direction. So we are spanning the whole world here on this class. So it's kind of fun that way. And then it's also being It's also being. What's that, Jovana?
I said it's not fun for us.
No, you have 3 a.m. or something. Yes, you got a lot of opportunities. Okay, well maybe I don't even need to pull this thing up. Oh, I was going to do a screen share, that's why I was going to do it. I crashed my other machine. I think I will wait to pull that up. All right, so any questions before we begin? I crashed my machine. I ran out of battery. Let me get this started again.
I'm on a schedule now, so I can't sleep at 7:30. I'll be at work.
So my audio is coming off of one machine and then the next, but I think this will be better for screen sharing the PowerPoint. All right, so we're in chapter 4 and 5. I'm going to try to do a screen share with the online people. I think will turn out the best, I hope. Sometimes I confuse myself because I've got too many screens going each direction, but let's see what happens. That way, these guys can see some of you guys. All right. All right, so let's see. Let me get the gallery back up. Thumbs up, you guys can see the screen share okay? Okay. All right, so now, once I do the screen share, you guys that are online, make sure you unmute and interrupt me if you end up having a question. It's probably the easiest way to do it because I'm shrinking my, I guess I could still see up there on that screen a little bit. So anyway, but it might be harder for me to do that now, so. Okay, so this is chapter 4, and this is on the marginal analysis stuff. So we've been spending a lot of time. How do we calculate average cost again? Average cost per unit. What are we doing essentially?
Total cost.
Okay, divided by the quantity. Whatever quantity you're producing, go ahead and divide it out. And so don't forget we've got fixed costs and variable costs, and but for what the author calls an extent decision, which I don't really like that language that much, but he's just trying to say to what extent or at the margin these changes make a difference. So we got the additional costs and the additional revenue that we spent some time on before, and that's what he's calling these extent decisions. So Let's take a look at some. Should you change the level of advertising? What belongs in that cost for your company? So maybe we could, let's talk about Ottawa University, since a lot of you are associated with OU. All of you are associated with OU, but a lot of you actually work for OU in some capacity with your graduate assistant. But you can also think of your company too. Those of you who work for, well, we have some people in the healthcare industry and some other places. So should you change the level of advertising? We're currently spending, you know, pick out a number, $3,000 a month. Should we change it? What goes into that decision?
Hey Russ, I don't think we're seeing the same thing.
You're not, okay. Oh, yeah, you're seeing that, aren't you? Let me do something here. Let me change a setting. Let's see, view.
Is there a way we can click on each PowerPoint slide as you're talking or not?
No, I'll be able to, I'm gonna do another screen here. I just have to remember which button I need to click. Presenter view, don't do that, okay. I think this should work. Let's see what happens. Share. And it's not working. Ah. Okay. Interesting. One more time. Give me one more shot. If anybody knows this better than I, feel free to speak up. But it's with your slideshow presentation. Gosh, I could have swore that was it. Monitor.
Is there an option at the top to start slideshow?
You know, it might have, let me try this again, because I think maybe your screen was just stuck for a second. Let me try this again. But now, why is this one stuck on that? Wait. Alright, let me close this off. Start from scratch. Okay, now, there we go. Okay, so now that one's good. So now let me escape. Go to Zoom. Go to screen share. Share that one. Share. Okay, and now through the magic of maybe trying to do too many things at one time. Ah! Yes! Alright, gosh, you had to close things out and do things differently. Alright. So, there we go. Okay. So, back to the level of advertising. What do we need to look at? What belongs in that decision? So, OU is currently spending $3,000 per month. How many of you have gotten those stupid, try Ottawa University, Ottawa, what did it say? Ottawaise it, or Ottawa made it, or Ottawa ability. Love it! What a campaign. So, you know, why are they sending Professor Russ Ottawa ability advertisements, right? So that's part of the dumbness of AI and social media. They don't know that I'm a professor, but they've heard me speak the words Ottawa University, so they think I might be a potential prospect to go to Ottawa University. So is that a good place to spend advertising? Well, I don't know. You know, I don't know if it's pay-per-click. I don't know what all their deal is, but I want you guys to tell me. We're spending $3,000 a month, which is a number I'm making up, by the way. It's probably a lot more than that. Should we change the level of advertising? What goes into that decision?
The benefit.
Okay, the benefit, and how are you measuring it?
How much people actually coming in from that or interacting with your ad or clicking the link that is associated.
New customers?
New customers, good, yeah, and how many people are coming in. So, but really, we got to think about how do we make money? right? How does Ottawa University make money? And it's mostly butts and seats, right? Having new students enroll. So you got to be kind of mindful of, well, how do we actually make money? If we're at the grocery store, we make money with beeps. Beep, 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 right? The revenue's going up. So at Ottawa University, we're thinking about butts and seats. And so part of that calculation on the revenue side, on the benefit side, would be how many people am I going to bring in, right? Is it 4 or is it 400? Do we know that going into it real easily? No. You know, the advertisers, you know, the pay-per-click stuff made it a little more of a variable. Like, we can't guarantee these people are going to come to Ottawa University, but we do know who clicked. And we knew who did double clicks, right? They clicked the first click, and then they read something, and then they clicked again. We've got that data. We've got big data, right? And so we will charge you, you know, 1 penny for a click and 3 pennies for a double click. Because a double click means you've got yourself a warm prospect. But we can't guarantee you they're going to buy your product, right? So that's what we want to be thinking about is on the revenue side. What about on the cost side? What are some things, Jonathan?
Never mind.
Okay, never mind. What goes into the cost? Developing, yeah, so there might be a development cost. So we might have to, you know, either the company does it and they have a setup fee, or we have to internally hire some GAs like Luke or Nate to come up with some advertising for our podcast or other things. So, you know, is there going to be incremental costs? So in the case of my GAs, since I went that direction with this, does Luke's cost to me, to the Gortney Institute, belong in the calculation of increasing advertising in terms of what Andres brought up in terms of the setup fee? So Luke and Nate, maybe I should say Luke and Lawson now, but Luke in the old days, which the old days were only 2 months ago, it would be Luke and Nate spending 3 hours coming up with something, coming back to McCullough, hey, what do you think of this? And no, I think it's terrible, go back to the drawing board and whatever. So we kind of jockey back and forth, and they spend 3 hours doing it. Does that belong in the calculation? Their 3 hours?
Oh, yeah. Not as GAs.
What?
Not as GAs.
Not as GAs. Why? Why do you say that, Jeremiah?
You don't pay them hourly.
Okay, we don't pay them hourly. He's not putting in extra overtime. They're still getting the pittance that they're getting, right? As they're getting, and the pittance, when I say, is the hourly pay, but you're actually getting what, $20-some thousand MBA, right? But we don't have to pay you more education. We don't have to add on a concentration or something to get you to do the ad. So that's all fixed costs. So there are no variable costs, maybe with the setup fee. But there might be other costs with, of course, whatever the advertiser is going to charge you. So if it's pay per click, or if it's something else, if there's setup fees. So only the thing, and of course, we've already covered this a couple times over today, the rent for the building doesn't belong there, you know, all of that stuff. It's just, what should we increase from 3,000 to 4,000? Maybe the, what we set up for a TV ad could now be done in online space. And so the setup fee is very minimal. We don't have to hire an outside company to do it, because we're just going to more or less cut and paste the setup fee that we did spend. We spent like $10,000 to have this TV commercial done with all the mock-ups and markups and stuff. But now we can just take out our little cut tool and plunk that into a static ad that's going to be a pop-up ad for the internet, right? And so there the cost is very low. So all of these decisions are to really think about, what are the incremental costs of doing that ad? What are the incremental benefits of doing that ad? Are we going to have 4 people or 400? And then if the benefits exceed the cost, do it. If they don't, right? That's what this whole section is really about. How about the quality of service at maybe it's your restaurant or something else? Should we increase quality of service? What goes into that decision? Let's go ahead and take a restaurant. Maybe it's fast casual, or maybe it's a sit-down, full sit-down. Chick-fil-A, okay? So, oh, you got the Chick-fil-A mug there. So what does it mean to increase the quality of service? It's like, yeah, let's do it. Let's be a high quality provider of chicken products.
People will pay more for high quality.
Okay, good. Will people pay more, right? And so we might have to start off with some assumptions that, well, if we make the average chicken sandwich is selling for $3, but if we make a really high quality product, we could get $4. What else goes into the quality though, besides just the chicken quality and maybe the seasoning and special sauce?
The labor.
Okay, the labor and the service, right? So are we having people clear their table for them? Are we having people come up and say, sir, how was your chicken today? Can I get you anything else? We have a special deal on ice cream tonight. Would you like an ice cream cone? They're on sale for $2. Some sort of upsell. What restaurant does that? Not too many. Waiter, a place where it's a full service restaurant might do something like that. But what if you started doing that at McDonald's? Imagine you're at Mickey D's, mowing down your Big Mac, and all of a sudden somebody comes up to you and says, sir, would you like ice cream today? I would love an ice cream, thank you. Yeah, and we're running a special, it's only $1.50. Okay, yeah, I'll do it, right? Would that be a step up in service for McDonald's compared to what they do today? Sure. But are they doing it? No. So again, maybe they don't think it's worth it. Do some places do stuff like that? Yeah, and maybe some mom and pop places might be able to pull that off better than some big corporate giant. Culver's seems to have pretty good service. I ate at there recently. I'm not a huge Culver's fan or anything, but it seemed like they had pretty good service. So yeah, that's the extent decision. What is the cost of increasing quality? What are the benefits? Are we going to be able to justify that in terms of higher prices or repeat business? Sometimes we don't need to increase prices. One thing that we'll touch on when we get to elasticities is if you normally go to Culver's once a month and we increase quality, will you now come twice a month? Right?
Yeah.
So if you come twice a month, that could be a value proposition worth doing because you're like, they always just make me feel right at home there and I really like their quality and it's nice that they clear your table. Like McDonald's never does that for me, right? And so all of a sudden you start providing this bundled product that maybe we'll be able to have profits go up because we have more people coming, not necessarily incremental prices. So that's another aspect to this. Do we have too much staff or not enough, right? Should we cut back? What do we need to think about? Jonathan?
We sound like the brothers for more or less than $1.67.
Okay, yeah, the more or less the 67. What is that extra Russ doing, right? So, do we have enough people? We talked about, I guess this last time with the grocery store. Do I cut some of my employees and run it thin? You guys have been at places where the line starts to get a little longer. Are people going to be upset that there's always long lines there and they don't really have it staffed properly? And again, maybe they'd go there 3 times a month, but now they're only going once a month because at Price Chopper there's never a wait, and they always seem to have shorter lines, and so that's worth it to me, right? I don't care that a pound of oranges is $3.50 out there, and at Walmart it's $3.25. I don't care. It's 25 cents. I'm thinking the overall experience of going shopping at that place suits me better. It's worth the value proposition. So parking spaces. How many parking spaces should you lease? So you got a big parking lot. What goes into that decision? Let me get somebody who hasn't spoke yet. Online or otherwise. Parking spaces. How many should you lease? So this could be an apartment building, it could be a commercial place, it could be a strip mall. What do we got here? Let's see. Jonathan, give me a number between 3 and 8. 6. 1, 2, 3, 4, 5, 6. We heard from you. We heard from you. We have not. Did I skip you? I didn't? Okay. Wait. Give me a name again. Vivian. So how many parking spaces should you lease? So you've got 100 spaces. Maybe it's your apartment building, maybe it's a McDonald's or something else, but you've got 100 spaces. Talk to me about the potential for leasing spaces. I'm talking in general terms here, so just kind of walk me through some of the things you might be wanting to think about. When you come to my class, you got to be ready to talk if you guys haven't figured that out. I want you and me connected with these things. We're here for a long time, so be ready. Vivian? So marginal cost, you can start with marginal benefit or marginal cost. You run a restaurant, what do you want? You want a restaurant or apartment? Apartment. So you got an apartment building, you got 100 spaces. What are some of the things that goes in the decision if you should rent some of the spaces, lease some of the spaces? You can think about the cost or you can think about the benefits. Where do you want to start, benefits or cost? Cost, okay? So you got 100 spaces, they're just sitting there. Currently used for just your apartment dwellers and their guests, I guess. Let's start with that being status quo. What's the cost? Wednesday night, 11 p.m. How many cars are in your 100 space lot? Wednesday night, 11 p.m. How many cars are parked in your 100 space lot? I'm asking you to open your mind. You can close your eyes even, it's kind of fun. You're looking at your parking lot right now. How many spaces are being utilized Wednesday night at 11 p.m.? How many? 80. All right, so we got 80 spaces. Should we try to lease out spaces? We've got some other apartments next door, and we also have maybe a strip mall or something nearby. Should we lease the spaces? You're saying we got 20 being unused 11 p.m. on a Wednesday night. Okay, so what would be the risk you'd be taking on if you did lease up the 20 spaces? Okay, and may some people not rent your apartments? Yeah, right, so that might be part of it. Other people chime in now, benefits and costs with this. Let's get some other people who haven't spoke yet. Yes.
Well,
and give me your name again, I'm sorry.
Maria.
Oh yeah, that's right.
The first thing that came to my mind is like if the apartments are like more like luxury.
Okay.
Maybe we would have some guests that would want to pay more to have like a closer parking spot.
Okay, good. Yeah, we might want to think about that. Sure. Do we have to bring in the price of the paint for the lines in the parking lot? Should that be a cost that's associated there? We have 100 spaces. They were painted 3 months ago. Do we need to bring in the painting of the lines? We spent $3,000 to have the whole parking lot painted. Does that belong in this decision right now? No. So right away, all we're thinking about is incremental additional cost, additional revenues, right? Are we going to bring in? If we can rent each space for $50 a month, that might be different than if we could only get $10 a month. So what do we think we can rent the spaces for? Are we going to have more vacancies at the apartment because the guests are mad that they don't have their friends can't find spots, right, for when they come to visit? So all of that stuff goes in, but you want to start with the status quo. You're not looking at the price of asphalt and the price of painting lines and other things. You're looking at the additional cost associated with making those spaces available and the additional benefits. All right? What else we got here? Okay, so all decisions in life are efficient if you start thinking this way. So my brain, I can't even escape it unless I drink a lot. Then I can sometimes. But Otherwise, like, I can't even brush my teeth in the morning without looking at this equation. What is the marginal benefit of brushing my teeth? What's the marginal cost of brushing my teeth? All right, I'm gonna brush my teeth for what, a minute or so? I gotta put the toothpaste on there, I gotta do it, right? And so what's the benefit? Well, I might avoid a cavity. Well, that's like a year from now, and I don't know, maybe my teeth are good without the teeth brushing. So do I have to brush my teeth today? Well, the dentists say that consistent brushing on a daily basis avoids cavities, reduces cavities by 50% or whatever, right? So we could start to think, okay, what's a cavity gonna run? Well, it's $200, but I got insurance, and so maybe the copay is only $100. So I start running through all of the costs associated with getting a cavity, but I may or may not get a cavity, but it's pretty low cost for the most part of spending a minute each morning, and I kind of like the fresh breath type of thing that I get out of it, so there's a little bit of benefit that way too, right? But if I'm late for class and I want to have a good reputation at OU, should I brush my teeth? That morning? Maybe not. It's too costly, right? Because now all of a sudden I've added at the margin that my class is going to see that I'm late, and maybe it's even just 1 minute late. Like, where's Russ? He's not here, he's a minute late, right? And so I don't want to consistently get into that. So depending on the circumstance, or maybe it's better like a job interview, right? Screw brushing your teeth, my breath isn't that bad, I gotta get out the door, my alarm didn't go off. So from day to day, you're doing this. You guys do this already, by the way. You just might not have ever thought of it formally with an equation, but you are doing this each time you enter a decision. What we try to do in economics class is to train you with the right things to put in the equation, right? Like the paint on the parking lot lines, that doesn't belong in there today for that decision, or this month or this year as we lease the spaces out. Okay, questions or comments there? All right, here we go. So let's get a little numbers. You'll start to see some of this in homework. $50,000 increase in the TV ad budget brings 1,000 new customers. Estimated marginal cost is 50. The cost to get one more customer, right? So we got 1,000 new customers, $50,000 incremental change in total cost. Change in total cost divided by the change in quantity gives me $50 marginal cost. So marginal cost of 50, and then how does revenue fit in? What do I need to get? Higher than 50. That's pretty simple. Once we start kind of get our juices flowing, as long as we get higher than 50, then we're going to be okay. Now, where it gets kind of interesting is if we have differential pricing, like our hot dog example. We're going to sell $2.50 for the hot dogs for the first 3 quarters, but then I might be stuck with some at the end, right? And so, do I use the dollar per hot? You know, is it $20 or is it the $70, or do I average them? You know, it can get a little thorny there of what's the right one. But on average, for all of the sales for that day over this time period, as long as I get 50, we should be doing all right. So give this a read. So what should you pick? So make sure we're all clear on this. You've got 2 bids. You're trying to get the 100 trees on your land gone. $150 per tree, or $15,000 for the right to harvest all the trees. We got 80% pines, which can be sold for $200, and 20% fir, which are half that value. The person who's cutting them down has $20 of cost. Gas, saw blades, labor, that's the variable cost, right?
Is that for both bids, A and B?
Yes. Yeah, the cost cutting is the same for A and B. So which one should we do, A or B?
B.
B. I'm hearing B. Go ahead and do chat box, you guys. Why don't we have everybody put a vote in so we can look at overall A or B. Now, wait a second, isn't it? What's 100 trees times $150 a tree? 15,000. So they're the same. So shouldn't we just flip a coin and heads we do A, tails we do B? Okay. So let me go to the, I want to see the chat box results here. Okay, so boom, boom, boom. Let's see, you guys can't see that because I don't have that. That's fine. All right, so Caleb, you've got, there we go. All right. B, option A will be likely to cut down and leave the pines. Okay, B, because everyone's going to receive more money. All right. So it looks like we got a lot of B's going. I hope I don't kill this whole thing by shutting that down. Okay, good. I think that worked. Okay, so what's going to happen in class here? I heard a lot of B's going on there, 15,000. What's going to happen if we do the A? What's the problem?
It's not worth it.
It's not going to be worth it. What are they going to leave? The furs. If your objective is to clear the whole land, we need to think about their extent decision, the person who you're entering the contract with. At the margin, they're not going to want to take the furs down, right? Because that doesn't make them the money that they're looking to get. And so with $150 a tree, we're making money with the pines, but not with the fir, and so we're going to have trees left over, right, at the margin. Whereas if the decision on the contract is $15,000 for harvest, what is now the marginal cost? Or maybe I should look at the benefit. What's the benefit now for them? Why are they taking all the trees, basically? If it's a $15,000, the right to harvest all of them. What's the harvester's marginal cost?
Well, the 15,000 is sunk, so the marginal cost is $20.
It's just the 20, right? So their marginal cost now is 20, the harvester, and so now for each one, they're gonna make $80 here. Whereas at 150, it was 20 plus the 150 is 170. Those didn't make sense. Okay, questions or comments on that one? All right, so looking at the margin. How about salespeople? So we expect the sales level to be 100 units at $10,000 a unit. Maybe we've got a hot tub here or something, so 1 million. Do we pay them 10% commission? 10% of 1 million is how much? 100K, or 50,000 flat plus a 5% commission. How much is that? 50 plus 50 is 100. So the business thinks, yeah, no problem. Doesn't matter, we flip a coin again, or which one's better?
Option 1.
Option 1. Why do you say that, Kim?
Because there is more incentive for the person to make the sell and get the commission.
Okay.
With it being a higher percent.
So we got kind of the feast or famine type thing, right? This is like real estate. I was in real estate sales, as I said in my example, or in my introduction rather. And so a 10% commission, all of a sudden, if I want to eat, I need to go out and kill something, right? But here, you got the $50,000 salary. Now, anybody say option 2? I think you can make an argument for option 2, that maybe that's not the best way with option 1 to have a 100% commission structure.
But if you have a $50,000 salary, it's almost that you know you're making $50,000, and the 5% is kind of like a bonus in a way.
Okay.
You know that you're going to make $50,000 no matter what. But if you know that your salary is strictly based on commission, I just feel that it would push you harder to make. It would force you to work.
But okay, so
then option 2, just because you don't have that safety net of having a set salary.
So where I want to go with this is, am I overlooking a good worker by only having this as opposed to this? Who am I potentially overlooking as the employer that might be a pretty darn good person? That's the error, right? You could go either way on this, by the way. So sometimes in business class in the MBA, we're thinking, oh yeah, commission's the way to go, because at the margin, they're going to work the hardest. They got to be hungry. They got to go. But who might we be overlooking if we have that structure? Who would like this one, maybe? That could be a really good employee for us. Who wants the $50,000 flat as part of the compensation? Families, yeah, that's what I was looking for. So you've got, you know, a newly married couple. They've got a 3-year-old, and it's like, gosh, honey, I don't know. You know, there might be other opportunities out there. We've got diapers, we've got food. You've seen what the inflation rates are at the grocery store. We got stuff to do, and so that particular employee might be looking for this, and they will still work their tail off to get the sales at the margin, but they kind of need that a little additional security to get started. We all do to some extent, but here, you know, if I was to put a depiction of who we're attracting, married or single person here? Single, which again, maybe that's fine, but how about turnover? Who's going to be more stable, the married person with the 3-year-old or the swinging single up here that's floating from job to job, commission to commission, right? I'm just bringing up kind of some issues that it's not always as easy to say, oh, this is going to get that person working hard at the margin. We might be overlooking somebody. And so companies kind of have to grapple with this, and it might be dependent upon their industry or their product or other things on how they set it up. So a lot of companies will have some sort of base salary. Now maybe it's $30,000 plus, you know, 7% commission or something like that. You kind of have to play with those numbers. But the worst thing you want to do is just attract a high turnover position that we're always having to retrain people and that sort of thing. Maybe we're overlooking some really talented people if we don't think about option 2. Okay, any other questions or comments there? All right. Okay, so we've got the hot shot of the company, the COO here, and this operating officer. So they get a flat salary of $75, but hey, they did an MBA and they learned about incentive pay, and they're like, we gotta jump on this bandwagon, and so we're gonna have the CEO with a $50,000 plus 1/3 of the profits above 150,000. So 50,000 base plus 1/3 of any profits above 150,000, right? So we're thinking, hey, I want to give this executive some incentive to really do something with this company, and we're going to do a profit sharing. That sounds good. Like, hey, those greedy capitalists, they're always taking all the money and leaving us poor folk behind. Well, let's do a profit sharing thing. All right, so we change it to that. Profits increased to 74% to 1.2 million, which means this person went from earning 75 to 177. Good deal? I mean, profits did increase. What are some issues with this? So we have $102,000, more than double what they were making before. Is that really the most efficient thing to do, or do you see any issues? Luke?
There's an incentive to kind of mess with the books a little bit there.
There can be, yeah. So sometimes companies struggle with, if we have a profit sharing thing and you're in control of costs, you might be able to shift costs from 2021 into 2022 and make, since I know I'm in the bonus for 21, or I know that I'm losing money, so let's just spend a whole bunch of money, make the loss really bad in 1 year in hopes that the gravy will be there the next year. So that's one monkey business that could go on. What else could be going on here with this that would be inefficient in terms of kind of passing the marginal benefit, marginal cost type of test? Jonathan?
Compensation is increasing at a greater rate than profit.
Okay, so compensation went up by 100+%, and that was more than profit. Okay, and so what would that maybe be signaling? I mean, do you just have a problem with your formula? You know, in economics class, we want to pay people the value. We have to pay people enough to get them off the couch and working for us or whatever, cover their opportunity cost. But at the same time, did this position, did he create all this 74%? What else might have happened that there was a 74% increase in profits? That all fell to this woman's shoulders here? She did it all? What might have happened? Booming economy or bust economy? Booming. Does she get all the credit for the booming economy? Jeremiah says yes, she helped the economy, the general boom. Not just the industry, but when the economy is booming, do all businesses do pretty good? Yeah, right? So in this case, we got to be careful with these types of profit sharing that we want the benefit to reflect the effort level and their contribution. And there's probably likely things here that were outside. You know, are there other employees that help contribute to the 74%? Absolutely, right? So how much did this one individual do? I think, Jonathan, you pointing out here the percentage increase in pay was more than what the profits were even, you know? So is there a good correlation between the compensation increase and the marginal contribution of this executive to the bottom line? And so there's probably a little bit of problem here. That might be too fat. And so as a profit maximizing owner, remember this isn't an owner, this is a manager, right? The CEO is working for the company. We might have said, you know, we kind of screwed up this formula a little bit. Whoopsie, I don't think this makes too much sense. Sheila was great, but she wasn't that great, right? Sheila probably would have been happy with a $25,000, maybe even $50,000 bump, but it didn't need to be a $102,000 bump. Okay, any other questions or comments on that one? Okay. There we go. One down. All right, so chapter 5, that was basically adding on to what we did before. So let's start in on this, and then I'm going to go back to the whiteboard here for a little bit. So this chapter looks at bringing time into the decision-making process. So we make a decision today to buy a machine, but that machine lasts 5 years. How do we take into account that we're doing something today that might be $1 million investment, but the benefits from that investment are going to trickle in over the next 5 years, right? But we had to spend this money today. And so this is all about the time value of money. All right, so here is an example with an apartment.
I don't think we got it on the online.
Okay, yeah, I see that now. Let's see if it's just delayed. I see that. Oh, I know why. Never mind. It's because I didn't share my whole screen. I shared one of the screens. Let me just do this. There we go. Okay, so give this a read here. All right, so now we get to pick on like Stormy. Who else was finance major in here? Finance, JC was finance. Who else is brave enough to tell me that they were finance? I know Stormy was. Anybody else online? Finance majors? Jonah. No, he's business administration, right? Oh, he's off the hook just like that. All right, finance majors. So, should we do this deal here? So the building's 95% occupied, so 5% vacancy, $550,000 in annual profit. Investors want 15% on their money. If they're gonna invest in this building, they'd like a 15% return on capital. So, $1 million investment, they want 150 grand coming in, right? So 15% on their investment. The bank offered a loan to Mr. Matthews at 80% of the purchase price at a rate of 5.5%. So the interest rate on the loan is 5.5%, and that means we have an 80% loan to value. So is this a good buy? What is the value of the property? What sort of offer should we make? I think I can do this on here. So how do we value things like this? There's multiple ways to do it. What's going on with this equation? Is the building worth $7.4 million? Is it worth $5 million? Is it worth $10 million? We've got $550,000 of annual profit. So how do we calculate what that's worth? Future value. What do you mean?
Calculate the future value of the investment at that rate in a certain amount of time.
Okay, so what I like to do is to create a timetable, and I recommend you guys all do this with these types of problems. This one's going to be a little bit different than that, but I want to think about it this way. So we got time period 0, that's today, and then we're going to own this thing into the future. So 1 year, 2 years, 3 years, 4 years, and on, right? Maybe we sell it after 4 years, maybe we hold it for 30 years. Whatever the situation is, we're going to think about the timing of flows here. So what's going on in time period 0 is we have an investment that needs to be made, right? Now part of that investment is going to come from the bank. So whatever we have for a purchase price, we're going to break it down into a loan plus a down payment, right? So you guys have seen that with car loans or whatever, right? So you have a loan amount and the down payment. And so the down payment is really the investor's chunk that they're having to cover. So in this case, we're going to be out the purchase price, so minus the price is one way to look at it, if we paid cash for the whole building. And then what are we getting in return? Well, after 1 year, we get $550,000. After the 2 years, we get another $550,000. We get another $550,000. We get another $550,000. So, of course, things might be different, but going into an investment like this, we have to make assumptions. So let's just assume, for now, that $550,000 in annual profit is our best guess at the expected return. So, how can we decide how much to offer over here? So, there's a couple different ways to do that. One is through the one tool that we use. It's called the capitalization rate, or the cap rate. So the interest rate, or the rate of return, let's kind of get to investing 101 here. The rate of return for a given year, the rate of return can be looked at as the annual profit. So the way this one's characterized, divided by the investment, or in this case, the way I have it characterized is the purchase price. So I'm getting $550,000. I'm trying to come up with a price, which is the value that I'm placing on the building today. And then what do my investors say they want? 15%. So how much would that need to be? We can just do the math backwards here and bring this number over here and this number over here. The price or the offer. By the way, I'm changing this a little bit from the way the problem is up there, just to bring in, I think this is a simpler way to look at it. I buy an apartment building at this price, 550 divided by, and if somebody with a calculator, that's 550,000 divided by the 0.15. What does my price end up being here? How much? 3.6. Those 3.6 million? Okay. So what I'm setting up here is you go buy a $3.6 million building and it's earning $550,000. You will earn a 15% rate of return on that investment. Questions on that? That's like the first little baby step, tiny little baby step here. We're going to get a lot more complex. But does that make sense to you? I gave up $3.6 million. The seller took it. I now own a building. That building brought in $550,000. And so I wanted a 15% return. So assuming that I got a 15% return and everything worked out nicely, then I am getting a 15% return on my $3.6 million building that I just bought. Yes? Okay, that's one way to analyze the investment. So it's kind of like earning a 10% investment on $100. I made 10 bucks, right? Yeah?
You can check it by putting your price and revenue back into the original formula and see if that gets a rate of return.
Yeah, you can kind of double check your work, but that and that's what we're doing here is just kind of looking at 3.6 million, boom, we're done. Now, what if I could borrow from the bank at less than 15%? What if I could borrow at 5.5%? There's a bank out there willing to do that. Would you then be able to offer more than 3.6 million? Yes, right? Because you're using other people's money, the banks, to do it. I'm not using all my investors' money. So that's where this equation comes in. So if I'm able to get bank money at 5.5%, we can calculate the weighted cost of capital. And my investors will not have to put in all 3.6. In other words, we don't have to pay cash for the building. We can afford to use the banker's money, and that will allow my price to go up. I can be more aggressive with my price. And so that's what's going on here. The weighted cost of capital, we have 20% is the down payment for my investors, cash on cash return, and then the bankers are going to take a 5.5% benefit out of it. So I have a weighted cost of capital of 7.4. Now we do the same equation, take the money, but now it's divided by 7.4 instead of 0.15, and that says I can make an offer of $7.4 million for the property. It doesn't mean I should, but that particular statistic, that calculation, would say it makes sense. So what are some risks that I'm running? They're kind of staring you in the face in multiple ways here. What are some risks? Let me go to the back. And I'm struggling with your name, so give it to me again. Aaron. What are some risks if I offer 7.4 million? What are some risks I'm taking as the investor here? The investors are buying the property now for 7.4, getting a loan from the bank at 5.5, putting in their own money to the tune of 20% of the 7.4. What are some risks?
Interest rate?
Okay, so is this interest rate going to stay the same? We could have a fixed rate over the life of the loan, so we could have negotiated that. It could have a variable rate, but there could be some interest rate risk. Okay, what else? Somebody else. There's
occupancy being reduced.
Okay, good, the occupancy rate. So this was assuming 95% occupancy. So if that drops to 90 or 85 or something, if the economy goes down because of, Russia-Ukraine conflict or other things going on, the government printing money that causes inflation, you name it. So now we're at a 90% or 85%. That's going to affect this number, right? So 550 was based off of the 95% occupancy. All right, other risk areas. You see any other ones?
The economy goes down and you have to reduce rent costs?
Okay, so rent costs, so maybe something to do with the, are you talking about like the upkeep of the building, or what, did you say rent costs? I didn't quite understand.
I mean, yeah, if like say the economy takes a turn and you've got to lower rent costs to get people in the door.
Okay, yeah, something like that. So there's lots of little risks going on here with this. You got to be, kind of thinking about those things on the front end of it. In this particular case, we had the financial crisis. So this was one of the author's real-world examples. And so they decided to buy the building. The building was, he did not buy the building, I should say. It went to 90%, which generated $500,000. So now with this number dropped to 500, so that right away is going to make the rate of return fall. And then we had the financial crisis, and the banks said we needed less exposure. That can happen. That's one that you guys didn't bring up that affected me personally with some of my real estate investments, that all of a sudden they're like, oh, well, I know we had a 5-year deal and I know we said we'd probably renew it, but they won't say it this way, but our bank's in trouble, and so we can't have that many loans out. And then other banks were feeling the same crunch, and so now our investors had to come up with additional funds for the building and bring that loan to value down. And now we have a less occupied building, and that's going to affect the rates of return. Okay, so all of that then changes this equation, and now the building at a weighted cost of capital, if we now shift this, we need the investors at the 35% level, 65 from the bank at 7.5% interest, 10% weighted cost of capital. Under that set of circumstances, we've got a $5.4 million building that we just paid $7.4 million for. So there is risk. Now it can go the other direction too, right? And so how do we hedge against that? Well, if you're a savvy investor, you might do the calculation that says, oh, I think this is reasonably worth 7.4. Let's offer 6. Let's offer 5, right? Let's deal. I'm not going to buy this building unless I can pick it up for at most 5.5 or 5.4. And so on the front end, you're weighing out those various risks that you face and kind of baking that into the equation. So we use these tools, but they're far from the end-all, be-all tool. Okay, questions or comments on that? All right, I'm going to go with a little board action here. And then we'll come back to the share. Okay. Let's look at the little more sophisticated version of calculating what something's worth. All right, the first thing I like to do is just a quick example of the time value of money equation. How many people know what that is? I'll just start with my finance people, just for fun. So, Stormy, what do you got for me? What's your best guess? Don't Google it. You're on your honor. It's okay to not know it. Although...
No, just say that one more time. I'm so sorry.
Present value formula. What do you got for me?
Oh, gosh. equals future value.
Okay, I like it, I like it. So that's wrong so far, but let's start. What do we need to do with those future values? Somebody want to help Stormy out? Divided by what?
1 plus the rate to the power of the time.
All right, to the power of the time periods, right? So n. So that's our present value formula, the most fundamental, important formula of finance. So let's see where that comes from. Suppose you've got $100 and you're investing it at 10%. What do you have next year in your account? If you earned a 10% rate of return, you invested 100. Class? 110. So you all kind of do that in your gut, but what you really did was 100 times 1 plus 10% gives you $110 for a 1-year investment. What if we let it ride for a second year? How much has your money grown to now if we let it ride a second year? 121. So where did that come from? We're going to take our 110 and let it ride again for a second year, and I get 121. Okay, everybody with me on that? That's like the simplest version of investing that we could do with a 2-year run on a $100 investment. All right, so now it's time to get fun with the math. If you notice, this sucker is this sucker, and this sucker equals this sucker. So let's put this sucker in for that sucker. Everybody with my John Madden analysis here? So what am I doing? I'm just going to take that 100 times 1 plus the 10% times the 1 plus 10% equals 121. How can I simplify this equation? I can square it. So this is like x times x, which is x squared. 100 times 1 plus 10% squared equals 121. And we're home free. We just derived the fundamental formula of finance. I ran out of board space. But the 100 is our present value. The 100 is our present value. So we've got the present value times 1 plus the interest rate raised to the 2 power, the number of years that we let the compounding go, equals our future value. That's taking our money and moving it forward in time. But when we're analyzing our apartment building, we've got money coming in the future, but I want to buy it today. So you need to bring this 550 in year 4 back in time. You need to bring this 550 back in time. You need to bring this 550 back in time, and this 550 back in time. That's what we're doing with the present value calculation. So here, but through rearranging the way JC had it, now we've got the present value equals the future value divided by 1 plus the interest rate raised to the n power, which is what, I guess this was a combination of Stormy and JC pulled it off there. So how do we find the value of $550,000 4 years from now? The present value of $550,000 divided by 1 plus the interest rate raised to the 4th power. What interest rate should I use? The rate of return. What rate of return? 7.4. Maybe. If that's the appropriate thing, if we have it locked in, so we can use the weighted cost of capital, right? So if that was the 7.4% with the way the numbers came out the first time with the part bank loan, part investor loan. Or if we're paying cash for the building like I presented here, then the investors are saying, I could get 15% in the stock market. Why the hell would I ever want to buy an apartment building? I got to get at least 15% for you to have me take my money and put it into your apartment building. You with me on that? That's the opportunity cost. The cost of something measured in terms of what you would have done had you not done what you did. So I'm not going with your apartment building unless you're covering my opportunity cost of keeping it in the stock market or some other investment where I think I can earn 15%. Maybe I've adjusted for risk or other things in that. So that would be, if we're asking the investors to pay cash for the building, and let's just ignore the bank loan for a second, then it would be the 15% level. So for the fourth year's product, those of you who have a calculator handy, what is this number? $550,000. If you value cash at 15%, what is $550,000 4 years from now worth to you? 314,464?
0.29.
Okay, we'll leave off 0.29. $314,000. Is that a pretty decent chunk off the 550?
Yeah.
Yeah, it really is, right? I mean, think about it. That's 550,000 big ones in your hand. We're claiming if that's coming 4 years from now, and I can have my money invested in an investment making 15%, that's only worth $314,000 to me, right? So we have discounted the future value of 550 into terms that now I can use to calculate whether I should buy this apartment building or not. That was just year 4. Now we've got to do year 1, year 2, year 3, year 4. If we're going to hold it for 30 years, maybe we'll go out 30 years, we can get an Excel spreadsheet and do this. Of course, we can enter in a formula on a spreadsheet or on a financial calculator and calculate what that is. That's what the value of the building to you is today using the future value formula. So this is just one of those calculations. So the value of the apartment building investment today, which is the offer price. This is the more sophisticated way than doing what we did here. The value of the apartment building, what I should offer, is the 550K divided by 1 plus the 15%, if we're talking back to this cash example, raised to the 1 power, plus 550K, 1 plus 0.15 raised to the 2 power, plus 550K over 1 plus I, or 0.15 raised to the 30th power, or whatever. However many years we're going to do this. And then maybe with Biden inflation, if we're lucky and it sticks around, my purchase price of the building has grown by 8% over the years. Pretty good deal, right? So real estate's not a bad thing to be in high inflation times. Same thing back in the 70s. So you get a lot of the get-rich people saying, go buy real estate right now because it's climbing. We might be in a bubble though, so maybe it's bursting, right? So it's a little bit of tug and pull here. But if we have inflation going on, then whatever purchase price I pay today, I need to factor that into the equation as well. That the value of the real estate might be higher 30 years from now. So I got lots of different things, but all of the things I'm talking about come back to this timeline. So if I'm looking at a 30-year window, I just have a 30 out here, and I say I've got 550 coming in cash flow, and then maybe I've calculated inflation. I think this building is going to be worth 30 million with an inflation rate of 4% on average, or 3% on average, right? And now I got to take this 30 million and tack it on to this equation, plus 30 million divided by 1 plus 0.15 raised to the 30 power. So I tack my sale price 30 years from now onto that and bring it back in time. If you're buying a classic car, I'm going to buy a classic car for $15,000. I'm not going to have much maintenance. I'm going to throw it in my garage, but I do have a storage unit. It runs $100 a month. So I've got negative $100 a month. I'm going to take it to a car show to keep it, have fun with the buddies and whatever. And so that's going to be a hold of the classic car. The classic car cost me $10,000. 5 years from now, the way classic cars have been growing, especially if it's a Mustang, GT, blah, 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 then I think it's going to be worth $17,000. Should I buy the car? right? Should I buy the car? I started with $10,000 investment. 5 years from now, I think I'm going to be able to sell it for $17,000. I'm going to have to pay $100 per month storage fees, but otherwise not too much costs during the hold. Is that a good deal?
How many years until we sell?
5.
With the maintenance.
Yeah, you should sell.
That's good.
Should do it?
They say,
So we're making what, $7,000? 10,000 minus the 1,000, $100. We're doing 1,000. That's $100 a month. So 100 times 12 is $1,200 a year. You see how you get all jumbled up with all that stuff? Take this framework and do it for your classic car. You can. The reason why I like to emphasize this a lot is because investing becomes really freaking simple if you train yourself to put it in this framework and you learn a simple little formula like that. What does it look like? Negative $10,000, purchase price today. 1, 2, 3, 4, 5. Year 5, I sell it for $17,000. So I have a negative $10,000 here, $17,000, but then I've got negative $1,200, negative $1,200, negative $1,200, negative $1,200, negative $1,200. So my gain here would be the difference between those two. All of a sudden it becomes easy. Put that into your stupid Excel spreadsheet. Get out your calculator. Do this calculation if you want to do it by hand. It's really easy. Should I do the classic car?
Yes.
I heard some yeses. How many people say yes? Show of hands online and in the classroom. How many people say no? Show of hands online and in the classroom. Nobody's saying no. Any other answers? Nobody's got it right. Everybody's wrong unless I hear anything.
You only make $1,000 profit if you take into account inflation.
Wrong! Anybody else? Online. It's the classic college answer. It depends. What does it depend on? What's your opportunity cost? If you are a grandma buying the hot rod and you have $1 million sitting in CDs at the bank earning 2%, what's your opportunity cost? 2%. So when you do your little calculation here of all of this stuff, your little 1 plus I is 1 plus 0.02. If you're a 45-year-old investor that's been pretty active and you feel pretty confident you can get 15% in other investments, your investment, or your level, your opportunity cost is 0.15. Those two answers are going to be dramatically different on whether grandma should buy the car, grandma likely should buy the car, our hotshot investor maybe not. It might not make sense at 15%. So the answer depends on your opportunity cost. That's why we call this economic art. There's not a right or wrong answer. It depends on your circumstances. How many of you are possibly interested in being like a wealth advisor? That got JC maybe a little bit. I mean, you don't have to have it as your goal, but that's why there's such a big industry of wealth advising. When you call your financial planner, are you talking to 75-year-old grandma or 45-year-old hotshot? Your investment advice depends on who you're talking to and what their opportunity cost is, right? What their risk tolerance is and all kinds of stuff. So everything's kind of customized. There's not a one-size-fits-all that's the right answer for everybody because everybody has varying opportunity costs of what they could do with their money. Okay, questions or comments there? All right, let's bring this thing back to life. here's our apartment building guy. Let's put that back up. Okay, so if my discount rate is 10%, would you lend or borrow to someone with a discount rate of 15%? Discount rate is your opportunity cost, the amount you're discounting money from the future at. Who's the lender, who's the borrower here? So if my discount rate is 10, would I be a lender or a borrower for somebody with a discount rate of 15? A lender? So your best thing is 10%. If your discount rate or opportunity cost is 10, you have opportunities that are 10%. Somebody comes along and they're willing to do investments at 15.
You're going to be borrowing.
You're going to be borrowing or lending to that person.
I said lending.
You said lending. Lending? So the reason to bring this one up is to think about the marketplace of borrowing and lending, right? So we've got grandma. It's probably a little easier to think about grandma back to the 2%. She just wants 2%. She's got $1 million. She's got a nice pension plan coming in from her deceased husband. She's set. She just lives humbly. She goes out and travels and visits her grandkids. Life is great, right? At a 2% rate of return, she's got $1 million. Is she a borrower or a lender with a 2% opportunity cost? Is she a borrower or a lender at her stage in life? She's a lender, right? She's happy with her $1 million being very safe, earning 2%. But remember, she's got it at a bank. What's the bank doing with her money? They're lending it. But who's the real lender? Grandma or the bank? Grandma, right? So that's the market for lending and borrowing, what we also refer to as the loanable funds market. But all of that is people, banks, and we kind of unfortunately have the perception that banks are doing the lending or something. But really we have a market of individuals with various preferences and stages in life and different opportunity costs. Those with low opportunity costs are the lenders. Those people who are willing to be a little more aggressive with stuff are the borrowers. And banks and other financial intermediaries just help bring borrowers and lenders together. Okay. All right, so companies have these same opportunity costs. We did the weighted average cost of capital. Time is important. And we can use the net present value rule. So do I buy the classic car? That's going to come up with a number, right? Or do I buy the apartment building at $550? I'm going to end up getting a number here, right? And so that number might end up being $5 million, according to my opportunity cost. And so I would be willing to pay up to $5 million, but not $6, right? And so that's what the net present value does for us, is it looks at the difference between the present value of the future income stream and subtracts off what you have to pay for it, the initial investment. And so if that number is greater than 0, then do it. I can't remember if my next slide has it or not, but let me tee that up before we even look at this one. You'll have a couple homework problems that look similar to this. So what I've been doing to set up the investment, so NPV, net present value, is equal to the present value of the future income stream, the profit stream or whatever, all the money coming in. That's what we did with the 550, 550, 550. The classic car was the 1200 negative, 1200 negative, 1200 negative, and then I finally sell it for 17,000. All of that is figuring out all these numbers coming back to present value, and then you're going to add them all up, and that's the present value of the future income stream. And then you're just going to subtract off what I like to refer to as the initial investment. which for our investors could be their down payment. It could also be the purchase price, whatever they have to shell out. With our example of the 20% down payment, it would be the down payment on the apartment building, right? And then you've got the future income stream calculated in. If we were paying cash for the building, then it would still be the future income stream, but we wouldn't have a bank loan down the road. So that would change things a little bit, minus my initial investment of paying cash. So that's our formula, and then here's our decision criteria. If the net present value is greater than 0, do it. If the net present value, if that number is a negative number, in other words, this number is bigger than this number, don't do it. Don't buy it, right? Then don't. And all this is a marginal analysis, similar to our marginal benefit, marginal cost thing. We've teed it up a little bit differently with this, but this is the marginal benefit, right? So if I kind of put this in here, this is the present value of the future income stream. That's the money I'm going to get. That's the marginal benefit. And the initial investment is the cost I have to pay today. That's the marginal cost. So all it's saying is if marginal benefit is greater than marginal cost, do it. If not, don't. That's all the net present value formula is doing for us. Okay, questions on that? All right, so what is the present value here? So here's setting up kind of a similar flow. We have outflow of $100 for this project, and then project number 1 has 115, and then nothing in time period 2. $100, 60, and 60. Which one should I do, project 1 or project 2? Do I want to make $20 or I want to make 15? 20 if I wasn't an MBA student and knew more advanced techniques of analyzing cash flows. What's wrong with the way most normal people, and by the way, you guys are normal people now, but once you get through the MBA program, you're going to think differently about life. What's missing with that type of analysis? Opportunity cost of what time, in what way? Yeah, but what else about time? What's different between this 60 and this 60?
That second 60 is not getting you as much as your first 60.
Yeah. This 60 is not as valuable as this 60. So it's totally incorrect to look at the 20 benefit because, I mean, just think about it if I price it to you this way. What would you rather have? I'm going to give you 2 choices today, you guys. $60 a year from now or $60 2 years from now? Which one do you want? You want it 1 year from now or do you want to just wait a couple of years? It's still going to be 60 bucks. What do you want? Now. I want money now. Why? Because I can do something with that money. You might go out and buy something with it. That's fine. You're just going to get the benefits of consumption faster. Or maybe you're going to take that $60 and invest it in something, right? So the point is $60 1 year from now is more valuable than $60 2 years from now. Let's check out the numbers. So for this problem, they've got a 14% cost of capital that they've calculated. And so inflow number 1, 115 is worth $100 today for this investor with an opportunity cost of 14%. 60 is worth 52. For the final though, this 60 is worth 46. So there's the difference when their opportunity cost is 14% of $60 in year 2 versus year 1, which gives us this net present value. Which one's better? Project 1. So 115 sooner is worth more. Okay, questions or comments there? Power of discounting, very important with investing, especially in long-term projects. Okay, so accounting profit versus economic profit, just a little reminder there on thinking about full profits. In other words, if you're earning 0 in economics class, that's okay because you're earning a normal profit. You couldn't do better elsewhere. It's not like you're making no money. right? So always remember, when we do the marginal cost calculation in this class, it has both explicit and implicit costs, which was our lesson from last week of accounting profit versus economic profit. Okay, so it's okay to have a 0 for a particular project. Just a comment here, we don't do too much on this, but some of you might be familiar with the internal rate of return. And all that's doing is taking this and solving for I if I know what the present value is. So the internal rate of return, if you go into a spreadsheet, instead of plugging it in like we've done, what if we say, I have an offer on the table of $6 million for this apartment building. Should I take the deal or not? Well, instead of plugging in the 0.15, let's just let the calculator or the Excel spreadsheet solve for the interest rate. When that interest rate comes back, it's going to say that generates an internal rate of return of 10%. If your opportunity cost is 15%, then don't do it. Don't buy the building, right? But if the internal rate of return turns out to be 20% and your opportunity cost is 15%, then you should do the deal. So I call it kind of the kissing cousin to the net present value. You're doing a lot of the same calculations, but in a different way. You're solving for the rate of return. We don't do too much of that. It'll be mentioned in the book, but you're not going to be doing those calculations. So, but if you were wondering, or some of you have had some other classes with that, that's the connection. All right, so what about break even? So a lot of times people like to think in terms of break even terms. So how many do we have to sell to break even? That's an interesting way to pose the question. And so if we bring in our profit equation of total revenue and total cost, we can kind of rearrange the terms to look like this. So what I'm doing with my profits is I'm setting them equal to 0. Of course, I don't want them to be 0. Profits equal price times quantity minus average, well, let me do the whole thing here. We'll do the whole enchilada. Minus average fixed cost times quantity minus average variable cost times quantity. So there's the total cost equation. There's the total revenue. And so if we rearrange the terms, your textbook will show you a little bit. You don't have to geek out on the math. You can just kind of look at this formula and probably get it, but I kind of wanted to tie it back to what I did earlier. So if we solve this equation for Q, we basically get this. Here's my rent for the building. I rent the building for $5,000 a month. How much would it take, how many units do I have to sell to cover that, right? And so my markup here is price of my product, $5, minus my marginal cost, which let's say is $2. So I'm gonna make $3 on every one of these I sell. If I do that, and I have $5,000 worth of rent, 5,000 divided by 3 says I have to sell this many units to break even. At least make a little fuzzy sense to you? Did I see some heads nodding? I know it's getting late into the evening. Just give me some nodding heads even if you don't understand. Maybe you just want to stretch out, a little roll the neck. The book will take you through that too, but that's conceptually what we're doing. How many units do I need to sell to force the profit equation to break even? And so that's kind of nice because then you can maybe solve some problems where there's uncertainty. So a quick little example, Nissan was looking to do a redesign, which would be $400 million worth of fixed cost. And so if they had a cost of capital of 12%, we've got the fixed cost of $48 million. Each truck was making $1,500. So in order to break even, following that formula, we'd have to sell 32,000 trucks, right? So they just went through the math, came up with, we'd have to sell 32,000 trucks. We're like, well, that's stupid. We've never sold 32,000 trucks. So let's scrap that idea, right? So it kind of gives you a quick quick and dirty, you know, it might be closer in some circumstances, but it kind of might be another way to look at whether you should do a decision or one other variable to calculate. All right, questions or comments there? All right, so last thing for tonight then is to look at the break-even price. How much money do I have to get in terms of sale to justify staying open? And so with this, I think it's almost easier to bring you, let me just, you guys already have this in your notes, but average variable cost, average total cost. What do I need to cover if this is, let's say this is $30 a unit, and this is only $7. In the long run, to make money, how much do I have to be able to sell my product for? In the long run, to make a positive profit, how much do I have to sell it for? 30, right? And this is just if I was operating at the minimum. So it might even be a little higher if we're at a different quantity, but at least 30. But would it make sense to sell it at $15? Should I stay open for business if I can only get 15 this week? Yes. Why? Because I'm covering all of my variable costs. My checkout clerk, the cost of inventory, the variable cost of production are being covered. And I'm also contributing $8 to my rent. So is that a good thing to do? Yes. Do you want more? Yes. But you should still be operating. So the break-even price brings you back to looking at your variable cost of production. You need to be covering your variable cost in order to justify staying open. All right, well that's a wrap for tonight. Nice job, everyone. Amazing how fast the time goes. I'll have you guys, if any of you have questions online, feel free to stay on. Otherwise, you're free to go, and we'll see you next week. We're back on for Tuesday next week.